Hi everyone, this is Navin Kumar Devraj. I am pursuing graduate study in information technology at Florida International University. Today I am going to present a project on transport level security. Let's look into the table of contents for today's presentation. First we have introduction. Next we look into web security threats. After that we look into web security approaches. Let's discuss on the protocol transport layer security and its application for HTTP, that is HTTPS protocol. We will have a conclusion. Finally, the reference slide that indicates the sources for this presentation. Now the introduction. Almost every business, most government institutions and large number of individuals now have websites. The number of people and businessmen who have access to internet is rapidly growing and they all use web browsers. As a result, firms are eager to set up e-commerce facilities on the internet. However, the internet and web are particularly vulnerable to many types of compromises. As companies became aware of this reality, the need for secure web services is increasing. When we look at this chart, we can realize that around 482 minutes of time is being spent per day with the digital media. So this shows that how much people are using the internet. Let's look into the web security threats. The web threats can be classified based on type of attacks. Eavesdropping on the network communication between the browser and server, as well as gaining access to material on the web, are example of the passive attack. Impersonating another user, modifying communication in transit between the client and server, are example of active attack. Another way to classify the web security is based on the location. So in the computer security, the web browser and server will be included for the security attacks. And for the network security, it would be the network traffic between the web browser and the client. Let's look into the threats, its consequences and measures that affect the CIA triad of the information security. For confidentiality, eavesdropping, theft of the information from server, theft of the data from client are the threats. And its consequences, loss of information, loss of privacy. And how it could be avoided is by using encryption and web proxies. For the integrity, the modification of the user data, modification of message traffic in transit are the threats, and the consequence is loss of information. It could be avoided by using cryptographic checksums. And the third, authentication, impersonation of legitimate users. The consequence is believe that false information is valid. It could be avoided by using cryptographic techniques. Let's look into the web security approaches. Based on the scope of the applicability and the relative location within the TCP/IP protocol stack, we can have a three type of approach. One way to provide web security is to use the IP security. This protocol is implemented in the network layer and it provides transparency to the applications and it is a general solution. It is implemented below the TCP layer. The next is like application specific security services can be embedded in the application layer itself. The advantage of this is we can tailor the needs of application. In this case, we have a Kerberos being implemented in the application layer. The third approach is general purpose solution, like we can build the SSL or TLS above the TCP layer. So it has two advantages. One is it is very transparent to applications, and also we can embed with the applications. And one of the best example is HTTPS. Let's discuss more about this TLS and SSL protocol. The transport layer security is designed to make use the TCP to provide reliable end-to-end secure service. It is not a single protocol. It is made up of two protocols, the upper and the lower. The upper protocol consists of handshake protocol, cipher chain protocol, alert protocol, and the lower is the record protocol. Let's look into each protocol one by one. The handshake protocol. This protocol allows server and client to authenticate each other and to negotiate on encryption algorithm and cryptographic keys to be used to protect the data sent in the TLS record. First, the client will send a client hello message that consists of a version that the client understands and a set of cryptographic algorithms the client will be supported. The next is the data compression methods. A list of all the compression methods a client can support is sent in this message to server. The server will reply back to the client with a server hello message. This packet consists of an agreement on the cryptography, the selected algorithm that could be used in the communication. It also shares the session ID to the client. Also, it sends the service digital certificate and also the public key. Once the client receives the certificate from the server, it will contact the server's certificate authority and verifies the digital certificates to confirm the authenticity of the web server. Once the trust is built with the web server, the client will share its secret key that to be used for further communication. That is achieved by sending a message client key exchange to server. Next, the client will send a finish message to server indicating that its handshake protocol is completed and it can go for next stage. Server, server also sends a message called finished with encrypted with a secret key to indicate that its part of handshake is completed. Once client and server establish completes the handshake protocol, both the entities can involve in the secure communication for further transactions until the session is terminated. So these are the steps that are involved in the TLS protocol, where client sends a client hello, server reply with server hello, client sends a client key exchange, then finished message, and server finally sends its finished message. Now let's look into the cipher change protocol. This protocol contains a single message which consists of a single byte with a value 1. The sole purpose of this is to cause the pending state to be copied into a current state. The next is alert protocol. It is used to convey a TLS related alerts to peer entity. Each message in this protocol consists of 2 bytes. The first byte indicates the severity of the message. The value 1 indicates it's a warning type and 2 is a fatal. And if it's a fatal, the TLS connection is terminated immediately. And coming to the alert. Alert can be fatal alert and a warning alert. The example of a fatal alert would be a bad record MAC, and for the warning alert, it could be unsupported certificate. Now let's look into the lower part of the TLS protocol, that is TLS record protocol. It provides 2 services for the TLS connections. First one, confidentiality. The handshake protocol defines a shared secret key that is used for conventional encryption of TLS payloads. The second is a message identity. The handshake protocol also defines a shared secret key that is used for message authentication code. The record protocol takes the application data to be transmitted, fragments into the block sizes, and compresses the data, adds the message authentication code, encrypts the message, and the resulting packet is sent to the next layer, the network layer. Similarly, the received packet is being decrypted and MAC is removed, decompressed, and reassembled and sent to the application layer. Now, let's look into one of the application of the TLS. Let's understand what is HTTP. It stands for Hypertext Transfer Protocol, and the protocol where a prescribed order and syntax for presenting the information is used for transferring data over network. Most of the information is sent using HTTP protocol. HTTP requests and responses are sent across in the internet in the plain text. So the problem is that anyone monitoring the connection could read this plain text, and the information like password, credit card can be read by the hacker, and it could be even manipulated. So we need to solve this by using security using the TLS protocol embedded in HTTP. That is called as a HTTPS. So as we see here, like in the when we have information from the website, that is a plain text is being sent to the server, there is no encryption part. And when we use a web browser, we can see that it's not secured. But whereas in HTTPS, the plain text is converted to encrypted, then it is being sent to the web server. The example is like there's a padlock symbol. So like HTTPS stands for Hypertext Transfer Protocol with secure, or in this the plain text is encrypted and transmitted between the web system. Finally, the conclusion. As we started our discussion of the general requirements for the web security and then focus on standardized schemes like TLS and its application to HTTPS. So this can be used for secure communication between client and server. And these are the references that are used for this presentation. Thank you.